Hello, welcome to another session of chemistry practical for 2026 NECO, determination of endpoint. This is on quantitative analysis. This is basically for chemistry teachers, those who want to, in your various schools, you'll be guiding your students to carry out this practical. You need to know how to report your endpoint. How do you determine your endpoint? Before we move on, please don't forget to subscribe to this channel. God bless you. This channel is committed to educating you and making you competent in what you are doing so you can be productive and excellent as well. So please help us like and share the video so that it can be a blessing to others too. God bless you. All right, so let's dive straight in. Now, for this 2026 NECO chemistry practical, we are asked to measure 4.0 gram per dm cube of sodium hydroxide, and then we are also asked to measure 2.7 cm cube of H2SO4. So those are the information provided in the instructions. For us to know the endpoint, the first thing is we determine what the concentration of H2SO4 in stock. We are asked to put this 2.7 cm cube of H2SO4 in 1 dm cube. That is the concentration for every portion of the H2SO4 that will be made available to students. You have 2.7 cm cube of H2SO4 in 1 dm cube. Now we are going to measure this 2.7 from concentrated H2SO4. That's the H2SO4 in stock. Have certain information that you need in order to do this calculation. So let's look at the first step now. Determination of the concentration of H2SO4 in 2.7 cm cube dissolved in 1 dm cube. For us to do that calculation, we need the density of H2SO4 in stock. So usually the density is 1.84. You will see it on the stock bottle. Then we have the concentration is this, and the percentage purity is usually 98%. We do this calculation. We usually consider the stock solution of H2SO4 has the volume there is 1000 cm cube or 1 dm cube, assuming the volume of H2SO4 in stock is 1000 cm cube. That's equivalent to 1 dm cube. Density is gram per cm cube. So from here now we can determine the mass in 1000 cm cube. We have the density, say we have 1.84 gram per cm cube. According to the density, we have 1.84 gram of H2SO4 in stock contained in 1 cm cube. How many grams will be present if we have 1000 cm cube? We want to find what will be the mass in the stock contain 1000 cm cube. Density tells us that we have 1.84 gram per cm cube. So that's 1.84 that contain 1 cm cube. So X will be 1840 gram. Please remember the stock solution of H2SO4 is not pure. The percentage purity is 98. So this is 1840 gram of impure H2SO4. I want to find the mass of the pure. So mass of pure H2SO4, that's equal to the impure mass times 98 divided by percentage purity is 98 times 98 divided by 100. So we are going to have 180 3 grams. The next thing is for us to determine the number of moles contained in this 1 dm cube. The mass contained in 1 dm cube or 1000 cm cube is what? 1803 grams. So what is the number of moles contained there? Remember how to calculate number of moles equal to mass over molar mass. The mass is 1803, but what's the molar mass of H2SO4? So that's 2 plus 32 plus 64, well, that's 98 gram per mole. Therefore, we have number of moles equal to 1803 divided by 98, 18.40, approximately 18.40 mole. Use your calculator, that's what you see. That means in 1000 cm cube, we have 18.40 mole. We can say that concentration of H2SO4 in stock in mole per dm cube is equal to what? 18.40 mole per dm cube. Remember, this 18.40 mole is contained in 1000 cm cube or 1 dm cube. So hope that is clear. First thing is we identify the concentration in stock. Now, sometimes this is the common figure for concentration of H2SO4 in stock. You may as well, except you want to know how to do this calculation. If you don't want, you may as well skip this step, but you just need to know that the concentration of H2SO4 in stock is 18.40 mole per dm cube. The next is concentration of H2SO4 in 2.7 cm cube in 1 dm cube. Using C1 V1 is equal to C2 V2. C1 is the concentration of the stock solution, which is what? 18.40 mole per dm cube. V1 is this stock. Now we are told to take 2.7. That's what is in the instructions. 2.7 cm cube. C2, that's what we want to know now. Since we have taken 2.7, we want to know what is the new concentration. And then V2 is, we are going to dissolve that in what? In 1 dm cube. So that's 1000 cm cube. Let's apply the formula. We are looking for C2, so let's make C2 the subject. That's going to be C1 V1 over V2. Going to be 18.40 times 2.70 divided by 1000. Right, so you can use your calculator. Answer is 0.0497 mole per dm cube. We are done with the first step. So we have now determined the concentration of H2SO4 that is contained in 2.7 cm cube, which we are asked to measure and put in 1 dm cube. So measure 2.7 cm cube and put it in 1 dm cube. The concentration is going to be 0.497 mole per dm cube. Step 2 is determination of the concentration of in 4.0 gram per dm cube. Don't get this twisted. This is also concentration. This is concentration in gram per dm cube. Now the concentration we are talking about here is in mole per dm cube. We already know the concentration in gram per dm cube. Now we want to find conc in mole per dm cube. Remember the formula that connects concentration in gram per dm cube and concentration in gram per dm cube, okay, is concentration in mole per dm cube is equal to concentration in gram per dm cube divided by molar mass. Okay, so from here we can also calculate the molar mass. We have the formula, and of course we know the relative atomic masses. So we look at molar mass of NaOH is equal to 23 plus 16 plus 1. So that gives us, that's 40 gram per mole. Now applying the formula, conc in mole per dm cube of NaOH is going to be what? 4.0 divided by 40. So the answer is 0.100 mole per dm cube. So we have done the first step was determination of concentration of H2SO4 in mole per dm cube contained in 2.7 cm cube in 1 dm cube. Now we determine the second step is concentration of NaOH in mole per dm cube based on the values what they ask us to measure. This is step 3. Now determination of endpoints. Now we have concentration of H2SO4, that's the acid. So we can call that as Ca, 0.0497 mole per dm cube. Now we have concentration of the base, that's we call that Cb, 0.100 mole per dm cube. Now remember we are looking for average volume of acid used, that's the endpoint. That's the acid we put in the burette. So that's Va. Va is the titer value, that's what we are looking for. And then we have Vb is the volume of the base. So normally that's the pipette. For this, we are going to use 25. We'll do for the two of them. So for those that are making use of 25 in their school or 20 in their school, you see your values here. My VB here is I'm using, that's for pipette of 25. So don't forget the equation for the reaction, that's H2SO4 plus NaOH, that gives us Na2SO4 plus H2O. Neutralization reaction gives salt and water. The equation is not balanced, we add 2 here, 2 here. Okay, that is balanced now. So that means number of moles of A, Na is what? 1, and Nb is what? Is 2. So we apply the formula that we using, that's CaVa over CbVb is equal to the mole ratio, that's 1:2. Okay, so we are looking for Va. Let's make Va the subject, that's going to be CbVb over C. Okay, so Cb is what? 0.100 times 25 divided by 0.042. All right, this is 2. So that's 2 times 0.0497. If you apply, use your calculator there, they approximately 25.15. If you are making use of a pipette of 25 cm cube, then your titer value should be 25.15. That's for those making use of a pipette of volume 25 cm. So we are looking at pipette volume now. So let's alternate the pipette volume. If it is 20 cm cube, Vb is equal to 20 cm cube. So if you apply Va to be equal to 0.100 times 20 divided by 2 times 0.0497 is going to be approximately 20 points. That's the titer value or the average volume of acid used. It's going to be 20.10 cm cube. Okay, so the titer value should either be this, that's for 20, those using 20 cm cube, pipette volume of 20 cm cube, or for those using pipette volume of 25, your titer value is 25.10. Alright, so you can use this calculation subsequent times you want to determine your endpoint before titration. You can use this method to determine that. Depending on if the reagents or the acid given to you is not H2SO4, then you take a look at the information given to you and then see how you can apply that. You can always come back to this video to watch it again and then learn some of the things that I've discussed here. So please do well to share this video, comment, you understand. If you have areas you think we can improve and it serve you better, I want to know what you feel about this video and how it has actually helped your understanding of what we have discussed. Thank you very much for joining me. God bless you. Please don't forget to subscribe.